Have you ever thought that how charge is distributed everywhere? So basically our point is charge distribution, right? So now charge can be distributed in two ways. The one is the uniform way or the second is the non-uniform way. So let's hear the first one is the uniformly, what we called as uniformly distributed, and the second one is, maybe I have to make it less, so the second one is non-uniformly distributed. Oh, non-uniformly distributed, right? So what uniformly distributed and non-uniformly distributed, it is basically what is like, here we have maybe an area, and in this area the charge is distributed everywhere, but you can see that how charge is distributed. So this is plus 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 plus, and plus charge is distributed all over the area. Now we can definitely say that the charge is distributed everywhere, but in a certain regions. So let's say in this region, the left side, the charge is more densely distributed, and in the right side area or maybe the upper area, we can say the charge is less densely distributed. So uniformly distributed, it is what basically, if the charge is distributed everywhere homogeneously, or maybe the charge distributed everywhere heterogeneously. So this is an example of non-uniformly distributed charge, because in the left side or maybe in the downside, in this area, we see that the charge is more dense, and in the upside area, in this area, we can see that the charge is less dense. So this system, actually this area, has a non-uniformly distributed charge. But if we take a same area, but now this time the charge is uniformly distributed everywhere. So let's say here we have a plus 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 plus. Now the distance between charges is same, almost same everywhere. So in that case, we can say the charge is uniformly distributed. So this is what basically the non-uniformly distributed charge, and this is the uniformly distributed charge, right? So since we know that how charge is distributed, they are distributed in a two ways, the uniformly distributed, maybe non-uniformly distributed. Now we can calculate their densities, right? So their what we called as density, and density refers to the charge per unit area, or charge per unit length, or maybe charge per unit volume. So what density tells you about that, the something is how many amount, something is inherent in how much amount in a particular region. So that's what called the density is. So basically our surrounding is made up of three dimension, that's what we called as one dimension, two dimension, and three dimension. So density, the charge density, can also be calculated in three ways. So first way is what we called as linear charge density. It is basically the density of charge in one dimension. So this is related to one dimension. Now the second one is what we call as surface charge density. This is what the charge density in a particular surface area. So this is related with the two-dimensional structure or two-dimensional area. And the third one is volume charge density. Now this is what actually charge is distributed, because the actual space is made up of volume, and the charge is distributed in a volume, never distributed in a certain kind of length or maybe certain kind of area. It's actually distributed in a volume. In some particular case, actually the charge is distributed in a surface area. Maybe in the later videos we study Gaussian sphere and we study the Gaussian surface, and at that place we study how charge is distributed in a surface area, the surface of a Gaussian sphere. So the volume charge density is basically related with the three-dimensional structure. Now, one by one we can calculate how linear charge density works, what is surface charge density, and what is volume charge density. So let's say our first topic, our first point here is the linear charge density. So now let's take an example. Here we have, let's say, a rod, right? And in this rod we have positive charges all over the place. So these positive charges are uniformly distributed. They are actually uniformly distributed. Since they are uniformly distributed, we can calculate their densities. So, but for the density, we have to donate how much charges it contains, the length here. So the total length here is basically L. So this is the total length L, and the total charge in this rod is basically Q. So basically linear charge density can be calculated. So first our is linear charge density. Now first I would say that the linear charge density is denoted by lambda. Now this is maybe a different letter for denoting the linear charge density, and this is what we call as lambda, right? And what lambda is? So it's basically linear charge density is total charge over total length, right? Total charge over total length. So now we can write it as the lambda is equal to total charge Q and the total length is L. So this is what a linear charge density says, that the linear charge density would be equal to the total charge per unit length. We can actually write it that the linear charge density is the total charge per unit length, right? So this is what linear charge density is. Now we can also write its SI unit. So what the SI unit would be? So SI unit of lambda, you can calculate it as well. So lambda is basically what is their formula? Its formula is total charge per unit length, means the total charge is measured is its SI unit is Coulomb, so we can write it as Coulomb, and per unit length, so the SI unit of length is meter. So this is what the SI unit of lambda, the SI unit of linear charge density is. So it's basically Coulomb per meter, or maybe you can write it as Coulomb meter ke power -1, right? So now since we have the linear charge density lambda, then we can calculate the surface charge density as well. So let's head towards the surface charge density. So here we have surface charge density. So surface charge density. Now the surface charge density refers to the density of charge in a particular region, a particular surface area. So here we have a surface area, which is, we can draw it like we can draw it like this and this. So in that surface area we have positive charges uniformly distributed. So positive, and there are so many positive charges which is basically uniformly distributed. Now in this region, the total surface area is A, and the total charge in that surface area is Q. So surface charge density represent that how much the charge is distributed in a particular area A. So surface charge density is basically denoted by this letter sigma. This is what we denote as sigma. So sigma is equal to the total charge over total area. So it's basically Q over A, right? So now we can write it as sigma is equal to Q over A. Now we can also denote their SI units. So what their SI unit is, which is basically Coulomb over meter square. The SI unit of charge is Coulomb, and the SI unit of area is meter. So we can write Coulomb per meter square, or maybe Coulomb meter ke power -2, right? Now we can head towards the volume charge density. So now our third point is the volume charge density. So volume charge density. Now first of all, the volume charge density is represented by a letter rho, right? This is what we call as rho. So let's take a volume first. You can take cube or cuboid or whatever a sphere for your volume, but I'm taking it as a simple cube, right? So this is the first side and this is the first area, maybe this, right? So this one, this one, this one, this one, and here we have a surface area, right? So all surface area which makes the cube, right? So in that surface area we can write the charges, we can represent the charges which is uniformly distributed. So these are the charges which are uniformly distributed in that cube, right? So now since the volume of a cube is V, or maybe if the side length is A, then the volume of cube will be A cube. And if the total charge is, let's say, Q, then we can write the volume charge density. The rho is the total charge per unit volume, so which is basically total volume. So rho is basically charge over volume, right? So this is what volume charge density says. Now we can also write its SI unit. So SI unit would be Coulomb per meter cube, because the SI unit of charge is Coulomb and the SI unit of volume is meter cube. So we can also write it as Coulomb meter to the -3. That's the power of the meter, right? It's actually Coulomb, the power of Coulomb is actually 1 and the power of meter is actually -3. So since we have studied what the surface charge density, what the linear charge density, and what the volume charge density, so studying the charge individually at once, it's basically time taking, and it's basically not possible. So that's why we have to study their distributions, how actually charge is distributed and how actually they are distributed in a volume, they are distributed in a particular surface area, or they are distributed in a particular length. You can apply it. So the theory is important. Now you get this.